All right, let's jump right in. Machine learning. I mean, you hear that term everywhere, right? But what does it really mean? Let's, for a second, just forget all the sci-fi stuff. In this explainer, we're going to break down this incredible technology using an example you've probably been using for decades, and you might not have even known it. So, when I say machine learning, what's the first image that just pops into your brain? Go on, be honest. Yeah, for most of us, it's probably something straight out of a movie.
You're probably thinking of some kind of super smart robot, right? Maybe a friendly one, or, if you've seen the movies, maybe something a little more Terminator. And look, that's totally fair. That's the image pop culture has basically drilled into our heads. But what if I told you that one of the most widespread, life-changing uses of machine learning wasn't a walking, talking robot at all? What if it was something that was already hiding in your computer, quietly working for you way back in the 1990s? Yep, the humble spam filter. I know, it's not exactly Skynet, but seriously, it's one of the most brilliant and earliest examples of a system that learned all by itself to make our lives just a little bit easier. And you know what? It's the perfect way to unlock what machine learning is really all about. Okay, so now that we've got our feet on the ground, let's actually define this thing. It's time to break down the buzzword. Okay, I know, this looks super academic and a little intimidating, but stick with me. This is the classic definition from a computer scientist named Tom Mitchell, and really, you can think of it as the DNA of machine learning. All it's saying is this: a program learns if it gets better at a job, the more experience it has doing that job. Simple as that. See? It's a bit of a mouthful, right? It's super accurate, but yeah, not something you'd say in a normal conversation. So let's translate this into plain, simple English using our trusty hero, the spam filter. This table makes it all so clear. First, you've got the task, or T. For our spam filter, that's simple. Is this email spam or is it not spam? That's its job. Then you have experience, E. This is the awesome part. The experience is all the data it gets to learn from. I'm talking about the thousands of emails that you and I have already marked as spam or not spam. Every time you do that, you're literally teaching the machine. And finally, performance, P. Think of this like its report card. How often does it get it right? The magic, the absolute core of machine learning is that as experience goes up, performance gets better. That's it. That's the whole game. Now, to really get why this is such a big deal, you have to see how things used to be done. Let's look at the old way versus the new way, because it's a total programming revolution. Okay, check this out. The old way, the traditional way, a programmer would have to sit down and write this massive, endless list of rules. Like, if an email says, "for you," it's spam. If it says, "credit card," it's spam. The problem? This list gets crazy long and is impossible to keep up with because spammers are always one step ahead. Now, with the machine learning approach, you don't write rules at all. You just show the program a bunch of spam and a bunch of good emails, and you say, "figure it out." The program finds the patterns on its own. What you get is a system that's not only way more accurate, but it's also resilient. It can take a punch and adapt. So that's the million-dollar question, isn't it? How does it actually adapt when the spammers get smarter? How does it keep up in this constant game of cat and mouse? This is really where you see the difference. So spammers start using the phrase, "for you." In the old way, a programmer has to jump in and write a new rule, block "for you." But what do the spammers do? The very next day, they just switch to spelling it out, "for you." And boom, that rule the programmer just wrote is completely useless. Now, the machine learning way. The system just watches. It sees a bunch of us humans suddenly marking emails with "for you" as spam. And from that experience, without any human getting involved, it learns. It figures out, oh, "for you" is the new spam signal, and it just starts blocking it automatically. So yeah, that's how it wins the spam game. But this amazing ability to learn and adapt, that's the real payoff. It's why machine learning is changing, well, pretty much everything. This learning ability gives machine learning some, actual superpowers. For starters, it can solve problems where we literally don't know how to write the rules. Think about recognizing speech. How on earth would you program rules for every accent, every slang word, every single person's voice? You can't. But you can feed a machine 1,000,000 hours of audio and let it learn. It also just simplifies ridiculously complex problems. Instead of 1,000,000 lines of code, you have a much smarter program. And as we saw, it adapts on the fly. It's perfect for things that are always in flux. But maybe the biggest superpower is this. It helps us find hidden patterns in huge, massive piles of data. We're talking about data mining. This is how scientists find tiny clues in our DNA that point to diseases, or how astronomers sift through petabytes of telescope images to find a whole new type of galaxy. These are patterns a human being could just never ever see.
So, when you boil it all down, if there's one thing to remember, it's this. Machine learning isn't really about making computers think like us. It's not about creating a human-like consciousness in a machine. It's actually about something a lot more practical, and frankly, maybe even more powerful. It's about giving computers the ability to learn directly from data and to improve at what they do, all on their own.
And that really leaves you with a pretty amazing question to think about. I mean, if a machine can learn to see patterns in junk email that we miss, what else can it see? What hidden patterns are waiting to be found in medical scans, in climate models, or in the endless darkness of space? What discoveries are just sitting there, right now, buried in the data, just waiting for us to find them?